Hello everybody, we're Group 11. We're presenting IEEE 802.11. My name is Andres.
My name is Isaac.
And we'll go ahead and get started.
So,
for our Wi-Fi introduction, Wi-Fi was first introduced in September of 21st, 1997, which so happens to be 27 years ago. And the protocol that we refer to as for when we're talking with Wi-Fi is IEEE 802.11. And that small picture that you see is the world's first commercial available product that utilized Wi-Fi, which was released in 1997 by Apple.
so the first version of IEEE 802.11 was in 1997 at only 2 megabits per second. The first major commercial use of Wi-Fi was in 1999 when Apple launched Airport with IEEE 802.11b at 11 microbits per second.
So before we continue on, we would like to clear up some Wi-Fi terminology so that as we go through the presentation, you know which generation we're referring to. So here's a small chart of all the different Wi-Fi generations, starting with Wi-Fi 0 all the way till Wi-Fi 8, and the respective IEEE standard starting from 802.11 all the way to 802.11bn, and the respective dates at which they were adopted, and the maximum bit rates that they allow.
So some of the obstacles that Wi-Fi encountered was interference between radio waves and wireless systems, security due to transmittance throughout open space, the theories surrounding overexposure to radiation leading to health issues in users. It was a small range due to physical obstacles such as walls or doors, windows even. So to overcome those Wi-Fi obstacles, they created a more diverse modeling for antennas for transmitting data on multiple paths. More antennas solved the interference issue. For stronger modeling led to more range for the paths, and the use of encrypting transmitted information for improvement of security.
Now we can go ahead and talk about some of the wavebands that Wi-Fi utilizes. Some of you may be aware of there are different channels that you can choose your Wi-Fi access point to transmit on. This is to avoid any interference with any neighboring access points or crosstalk with other devices that may be nearby in the network. And so to start off with the most common 2.4 gigahertz frequency, you typically have from 1 to 11 channels in the United States. That being only 1, 6, and 11 being non-overlapping channels, meaning that if you have 3 different access points in those 3 different channels, even if you have it at the maximum bandwidth, they will not overlap, so the interference between them will be minimal. And for the 5 gigahertz and onwards, you have even more channels. As you can see, the 5 gigahertz channels can have up to about 100 channels, allowing for a lot higher density devices to be connected to. And this helps in large metropolitan areas such as hotels and apartment complex where you may have a lot of different access points. However, some channels do allow for slight channel overlap. This is to maximize the amount of channels in the spectrum. But essentially, when transceivers have to transmit, they do have to wait until they can transmit. So not all Wi-Fi channels nearby can actually be utilizing the same channel at the same time. So interference can occur when these devices can be transmitting at the same time. Wi-Fi also utilizes OFDM, which is a standard available in the 802.11 A, B, G, and N flavors, and OFDMA for newer standards such as 802.11 AC and AX. Now we'll go ahead and talk a little bit about signal multiplexing. Essentially, most wireless communications are done in halftime or half duplex, unlike a Ethernet connection where it will be a full duplex connection. Wi-Fi communications or pretty much any wireless communications are limited to half duplex, meaning you can only transmit and receive one or the other, but not at the same time. We modulate these transmissions on multiple carrier frequencies, and this allows for increased packet transmissions during busy or strained conditions. There's a small diagram here that you're looking at that is a TDMA, which is an honorable mention, and it was used in older legacy GSM systems, but it's also similar to the 802.11 application here. As you can see from the diagram, there are certain time slots or frames which the access points or the transceiver is allowed to transmit on, and so the both the user equipment and the transmitter negotiate a time at which they can both transmit and listen to each other. Now we're going to go ahead and talk a little bit about access points, repeaters, and mesh systems. There are different types of devices that you can utilize in Wi-Fi. The most common being an access point, which essentially takes a wired connection and makes a wireless connection. You can also have a repeater, which takes the existing SSID or a Wi-Fi network and just retransmits it in either in the same channel or in a different channel. Or you can have a wireless meshing system which utilizes a wireless uplink from other nearby access points and retransmits them into another wireless local area network. And lastly, a little bit about MIMO. In newer generations, first starting from Wi-Fi 4 and above, we have a protocol called MIMO, which stands for multi-input, multi-output. Essentially, you can think about these as like lanes on a highway. The more lanes you have going one way, the more data you can transmit through. So these higher end radios, such as this one that you're looking here by Ubiquiti, allows for very high density devices to be connected to. As you can see, this device can allow up to 1,500 connected devices, and this is because it has a 4x4 MIMO. So it has 4 lanes for download, 4 lanes for upload, which allows for a lot of throughput. And lastly, we have here a real-world example of a wireless network utilizing 802.11 standards. You can see all the 5 access points on the top and all the respected connected user equipment at the bottom.
So the Wi-Fi evolution consists of the Wi-Fi 6 and 6E, which is what we're currently using, which is IEEE 802.11ax. It was founded in 2021, and the purpose of this was to offer a higher bit rate of 9,608 megabits per second, while also operating at 6 gigahertz. This created an overall better performance in crowded areas. It's supposed to have a more complex signal multiplexing, such as OFDMA, which offers more sufficient use of time. What's up and coming is that it's going to be projected in 2024 or early 2025 Wi-Fi 7, 802.11be, which primarily focuses on WLAN indoor-outdoor operations at 23,000 megabits per second. Projected in 2028, however, is the Wi-Fi 8, which is 802.11bn, which focuses on reliability of Wi-Fi in a wide space and at a whopping 100 gigabits per second. Here are our citations and our references that we used, and thank you guys for watching.